Okay, thank you. I'm Ryotaro Temma from Takashima University, Japan. I'm going to present third-person perspective, increasing situational awareness using a spatially coupled second drone. This work was done with Kazuki Takashima, Kazuyuki Fujita, and Yoshifumi Kitamura from Tohoku University. Also, this is a collaboration with Sueda from National University of Singapore. This is an example of traditional drone controller manipulation. In this case, drone pilot may concern for piloting the flight path to keep the working man in the frame, because no information of moving direction is provided. Our approach is using additionally coupled second drone that is flying orbitally around the primary drone, which keeps capturing its surroundings. The second drone additionally provides a third-person perspective, which helps pilots' spatial understanding because additional camera covers blind area. Here is background. A major application of drone is videography. Drone allows us to take attractive footage, but such three-dimensional manipulation is so challenging. This is why it is challenging. Often drone's camera direction is different from its moving direction, where it becomes difficult to comprehend the spatial relationship of surroundings, which decreases pilot's situational awareness of surroundings. By the way, on-drone collision avoidance system is not available. It ensures safety piloting, but it doesn't provide three-dimensional information around the drone for the pilot. So which means it doesn't directly enhance situational awareness. Therefore, there is strong need for the better control interface to satisfy interactive and dynamic manipulation that enhance situational awareness. Providing a third-person perspective is a well-known way to increase situational awareness. For example, if you walk the street, you don't know how the street goes from current position. If you additionally have a third-person perspective based on bird's eye concept, you can easily get wide area of spatial information of the street. Then you are able to plan walking paths more effectively. For this topic, many researches have been done. In the field of teleoperation, a major approach is generating third-person perspective from onboard sensors of remotely operated robot or vehicle. It is very powerful, but it could generally have blind area. There's another approach. In this research, it provides a third-person perspective from a bird's eye camera from the drone, which fly over the ground vehicle. Here, real and wider information is provided, which covers blind area and helps path planning. But this third-person perspective is static viewpoint. For drone's three-dimensional manipulation, this is not sufficient because the proper viewpoint is dependent on the situations. In the summary, focused on drone manipulation, we need more situational awareness. Collision avoidance system doesn't enhance situational awareness. Third-person perspective from onboard sensors enhance situational awareness, but the occlusion problem exists. Third-person perspective from bird's eye camera also enhance situational awareness and solve occlusion problem, but interactive camera control is not considered. So we believe interactive third-person perspective from bird's eye concept camera is quite promising for drone manipulation. And the challenge is how we can manage two cameras by the single pilot. In the area of virtual environment, there are many researches that work on interactively control multiple cameras, first and third-person perspective, and so on. This is one of these researches. This works on a unique algorithm of managing user view and bird's eye view on virtual environment. In this virtual environment, there are two cameras, primary and additional viewpoint, and the user has a plane as a controller. System tracks user head and the brain. There is a mapping of relationship between the user and the brain and the two cameras arrangement. If the user rotates the brain controller as look around the brain, auxiliary viewpoint camera in the virtual environment moves around the primary viewpoint. Transition as well. Moving the brain changes the distance between the two viewpoints. We believe this tangible approach allows controlling two cameras. And then we attempted to bring this into the two-drone manipulation. Here, we propose third-person piloting. Here is custom drone controller of our proposed interface. We use conventional two-joystick controller as a basis, and we put a miniature drone with a smartphone on a free rotation mount that allows the pilot to change the second drone's position. Two more smartphones are placed on the controller side by side to display first and third-person perspective. This is a relationship between the primary drone and the second drone side, and the miniature of the primary drone and the pilot eye side. In this slide, this relationship is visualized as blue triangles. If a pilot tilts the miniature, the second drone is automatically repositioned so that these two triangles of both sides are maintained as to be same. Now we show horizontal control. Here are the pilot's eye view and the third-person perspective from the second drone. Now the pilot sees the miniature from its back, so third-person perspective from second drone captures the primary drone from its back. If you rotate the miniature to see its left side, the second drone tries to capture the primary drone from left side. Also, if you rotate the miniature to see its right side, the second drone tries to capture the primary drone from right side. For vertical control, if you rotate the miniature to see its top, a top view is provided. Also, if you rotate the miniature to see its backside, the second drone flies same level as the primary drone. We design and implement an actual working prototype with commercially available drones. Mainly, pilot uses the primary drone controller to control the primary drone. Then, primary drone sends its GPS location to the ground station. Also, posture of the miniature is sent by the smartphone to the ground station. Then, the ground station calculates the target GPS location of the second drone with our algorithm and send it to the second drone together with the primary drone GPS location for gimbal control. In these settings, our brief test confirmed that workflow latency is affordable and drone flies enough responsive. We consider the 4 operation techniques. First one is horizontal positioning. In this situation, you may want to locate the primary drone to the middle of the obstruction and the shooting target, while keeping heading of the primary drone to the target. If you do this by only using the first-person perspective, it might be quite difficult because no information of surroundings are provided. By using our interface, if you rotate the miniature as you see its left side, you can understand the exact spatial relation among the obstruct shooting target and the primary drone from the third-person perspective. The second one is vertical positioning. In this situation, like inspection, you may want to keep the distance between the ceiling of the bridge and the primary drone. This is also quite difficult because depth and height of the primary drone are unclear. By using our interface, you can see exact spatial relationship among ceiling and the primary drone from third-person perspective. I'm sorry for bright sunlight for unclear. I will discuss this visibility issue later. The third one is scanning. By rotating miniature roughly, you can scan 360 degrees of surroundings, and it drastically helps pilot to decide the next motions or path. The last one is following. If first-person perspective capture walking man, pilot has no idea of lost shape of its back. For example, if you place the second drone at the front of the primary drone to see its back, you can comprehend the lost shape from third-person perspective, so you can easily plan flight path. This is a unique example that cannot be done with only single drone. For this very first stage, we gathered user feedbacks on usability, situational awareness, and future improvements. We used two tasks to examine common drone situations. One is videography task. Here, the primary drone should follow a moving target while keeping distance. Another one is exploring task. Pilot explores 3 different landmarks following a predefined order. These tasks contain several operation techniques that we proposed. We have 3 different skill levels of participants: novices, advanced beginners, and experts. Let me introduce brief result and SUS score. From novice, 2 of 3 agreed our proposed interface. From advanced beginners, they all strongly supported our interface and had high SUS score. From experts, they all positively agreed and gave us lots of insight of the future improvements. Situational awareness is defined as 3 levels: perception, comprehension, and projection. Satisfying higher level is much better. For perception, pilot can always see third-person perspective from second drone. Also, we obtain such general positive comments for the interface itself as it is easy to understand. For comprehension, all participants commented that the second drone was helpful for understanding the primary drone position. For perception, we don't have a consensus. However, we got several associated comments, able to plan how to move the drone to the start position. We believe that such smooth drone manipulation cannot be achieved without future projection. From this feedback, we confirmed that there is the potential to increase situational awareness in our interface. Further investigation is needed. We assume that most drones will have a collision avoidance system, and thus the safety of the second drone will be ensured in the near future. However, it remains unclear how much synergy will be created by the combination of such automatic collision avoidance system and our multi-perspective approach. Our study identified critical difficulty of recognizing the primary drone's head orientation and the depth relationship between the 2 perspectives. So we should explore other camera lens settings, virtual highlighting, and display devices. Control configuration should be also explored. We got suggestion that pilot confuse which display is third-person perspective or not, even there are the labels. Virtual separation and settings of screen size will affect visibility. Also worth trying for user study. And there's many future possibilities that extend our work. For example, swarm or third-person perspective will provide more viewpoints at the same time, and the pilot can change view among them instantly. In this research, we focused on manual manipulation. On the other hand, free automatic second row positioning is also interesting. For summary, we propose third-person piloting a novel drone interface, increasing situational awareness by providing an interactive third-person perspective from a specially coupled second drone. We designed and implemented a proof-of-concept prototype using a commercially available and programmable drone. User feedback suggests potential of our interface for increasing situational awareness. Thank you.
right. Questions while the next speaker sets up? All right, well, I had a quick question. So I was really curious about going beyond just one additional camera drone. So you mentioned swarming at the end. Could you say a little bit more about how that would potentially benefit? You mentioned switching camera angles more quickly. Are there other things that you can do that you fundamentally can't do with only one extra camera position?
So you mean, is there another settings for third-person perspective position?
If you have a swarm of additional cameras.
Yes. If there is many swarms about the primary drone, you can pilot can see the several viewpoints at the same time. So pilot can choose the best viewpoint for each situation. So pilot can plan the flight path more effectively, we think.
All right, great. Any other questions? Let's thank